What are called rational functions, which are essentially functions that have a numerator and a denominator with a variable in each one of them. All right, so they look like fractions. The thing about rational functions is when you get a variable in the denominator, what happens? Yes. Well, x can be 0, but the bottom can't be 0. That's what you meant. Yes. Okay. So we cannot divide by 0, right? This makes no sense. 1 divided by 0, you cannot do it. So we have domain restrictions. So for instance, in this function here, this first one, what is x not allowed to be? 1. What about this one? What would make the denominator 0? Positive and negative 3. That's correct. And the last one would be x cannot equal 2. Negative 2, sorry. We've already done that when we did functions. I asked you to list domain restrictions when we were dividing functions, and that's what you did. Now we're going to look at the graphs of these functions, and these domain restrictions have implications in what the graph looks like. So you get what are called discontinuities in the graph, and those can come in various forms. For Math 12, we're going to look at vertical asymptotes, so you'll get graphs that look like this. Okay. And there's a line that they can't touch. We can get points of discontinuity, which are just holes in the graph. We're going to look at those today. And if you go on to take calculus, you can get jumps in your graph, things like that. So you get really weird graphs. We only look at the first two in Math 12. Are we okay? All right, so what is an asymptote? I've told you horizontal asymptotes. We're going to look at vertical asymptotes right now. If you flip the page, we're going to look at the graph of 1 over x minus 1 here. And specifically, we're going to look at what happens when you approach the number 1. So if I put 1 in here, I end up with 1 over 0, right? Which is impossible. So there we go. So if I put 1 in, we're not going to do this one. So if I put 1 in, I can't do it. We're divided by 0. But what if I put in numbers that are close to 1? What is happening? So if I put in 0.5 into this graph, 0.5 minus 1, negative 0.5, 1 over negative 0.5 is negative 2. Like, okay, so let's put in 0.9. Let's get a little bit closer, because negative or positive 1, what makes the denominator 0, is this line right here. So 0.5 is like right there. Now I'm going to move a little bit closer. Line from the left side. So I put in 0.9. If I put in 0.9, I get negative 10. So now the graph has moved way down here. The point is like way down there. And if I move even a little bit closer, 0.99, I'm going to get negative 100. Oh. What if I moved 0.999 away? What number do you think I'm going to get? Negative 1,000. So what's happening is as you move closer to this line from this direction, the graph is accelerating down. It's going crazy. Every 0.01 or every, well, not 0.01, but every little increment I get closer to 1, the graph's value decreases dramatically. Okay, and it just keeps accelerating down. So when you come from this direction, the graph is accelerating down like that. You can never get to 1. So when you draw a line that gets close to an asymptote, you just draw it sort of close to it, but you can never touch that line because if you hit 1, you're dividing by 0, which you cannot do, okay? And just to complete this graph looks like that on that part of the curve. I'm not worried too much about this right now. But as we get closer to 1, the graph all of a sudden just starts to fly down. Now, what if you come from the other direction? This side of 1. So if I put in 1.5, I get 2. If I put in 1.1, I get 10. 1.01, I get 100. So as we come from this direction, the graph is accelerating up, okay? So the graph's coming, we start to get close, and then it just takes off like this. And hopefully you can draw a better graph than I just did. My shaky hand. Cool. Basically what we would say is we would say the graph approaches infinity, okay? Is that okay? Clear as mud? All right. The line is, the vertical asymptote in shorthand is basically what makes the denominator 0. That is your vertical asymptote. I'm going to define it later on, like there's a summary page at the end of this. So whatever makes the bottom 0 is your vertical asymptote, okay? All right. That's basically what this is saying. We're going to look at this graph, and we're going to sketch this graph. So 3 over x. State the domain of the function, i.e., what can x not be? 0, right? Because if x is 0, the whole thing blows up. So my domain is x cannot be 0. It can be anything else, so we should write xer, but it cannot be 0. All right. Excuse me. So we have a vertical asymptote at 0, which we represent with a dashed line. The horizontal asymptote for now, we're going to change that in a bit, is going to be y is equal to 0. So it's there. Okay, we are going to sketch this graph. 3 over x. So if you don't know what this graph is going to look like, you test points, okay? So test points on either side of the vertical asymptote. And I'm going to write VA for vertical asymptote. Because we need to see what quadrant the graph is in. Okay, so what would be if we test the point on this side, the right side of the vertical asymptote, what would be the easiest point to test? X is equal to what? 1, right? Because we can't do 0 because that is the vertical asymptote. So if I just test x is equal to 1, I put into that function. I get 3 over 1, I get 3. So at 1, we have a value of 3. Then you should test the point on the other side. What would be the easiest point to test? -1. And I'll end up with -3. So at -1, I get -3. Okay. You can't touch the vertical asymptote. For now, you can't touch the horizontal asymptote. So the only way this graph can exist, if I can't touch this line or this line, the graph has to look like that. Because it has to go through that point. All right? Is that okay? And it has to get close to the vertical, but it can't touch it. So it's just going to accelerate up. Same with this part. Has to go through this point, can't touch either line. So there you go. That's the graph. Are there any questions about that so far? You don't understand the points? How do I what, sorry? So I just picked a point that is to the left of the vertical asymptote. So x is equal to 1. I put it into there. 3 over 1 is 3. So it has coordinates of 1 and 3, that point right there. And then same for x is negative 1. Okay? You can pick any point you want. As long as it's not x equals 0. It has to be to either side of that. Okay? Crop in the view. Okay, this is calculus. The definition of a horizontal asymptote is what is the graph doing as x approaches infinity? I.e., what is the graph doing? We don't really look at them too much in this class. There is one example that we're going to look at today where it does, but I'll show you how to determine that. So when I say you can't, that's a bit of a misleading statement. You can when it's close to the origin. Okay, so it's just the definition is just what does the graph do? What line does it get close to as x gets really big? That's the definition. But that gets into calculus, so we don't really talk about the why. So you just have to know that it'll get really close to this line, the horizontal. Yeah, because it's going to move. That's what we're going to do right now. Because it's not always 0. It moves up and down as well. Madison. You sure? Okay. Anything else? Those are all good questions. It's hard though, because we're moving through this quick, and so I can't give you as much as I want. But basically, it's just you get close to the horizontal. But you can touch it, and there is an example that we'll look at. Sorry? Not every equation. Just this one, because it's just an x in the denominator. So if I put 0 in there, I'm dividing by 0. But what can't happen is you can't touch the vertical. That's a hard rule. You cannot touch the vertical because you cannot divide by 0 in math. Okay? All right. We're going to skip this and come back to it. We're going to go to page 472. And we're going to look at horizontal asymptotes. How do you determine what they are? So vertical asymptotes are straightforward. They are what makes the denominator 0. All right? Whatever makes the denominator 0 are your vertical asymptotes. Horizontal, there's 3 rules. There's pseudo rules. They're shortcut rules because you don't know enough calculus to do it. We learned the actual definition in calculus. But so these rules will work. Okay, first rule, and you need to know this stuff. So this should be on your study guide for sure. Horizontal asymptotes. Now I'm going to read it and then I'll explain what it means. If the degree of n of x is the numerator, is less than the degree of d of x is the denominator. So I'll just say this is the top, this is the bottom. Then the line y is equal to 0 is a horizontal asymptote. Okay. I don't like this example, so we're going to do this. All right, so there's our function. X squared plus 1 over x cubed minus 2x squared plus 1. What is the degree of the numerator, the top? 2. Remember, degree is the highest exponent. Okay, So the top has a degree of 2. Bottom has a degree of 3. Since the bottom is higher than the top, the horizontal asymptote is y is equal to 0. Okay? If the degree of the bottom is bigger than the degree of the top, the horizontal asymptote is 0. Again, the y is a little more calculus, but what it means is the value of the bottom is getting bigger faster than the value of the top. It doesn't matter if you know that. What you need to remember is the rule. Okay? That you need to know. Number 2, if the degree of the numerator and the denominator are equal, then you look at the leading coefficients. So the degree of the top here is 1. The degree of the bottom is 1. So then you look at the leading coefficients. And your horizontal asymptote is 2 over 1, which is just 2. Okay? It's just the ratio of the leading coefficients. That's it. And the final one, if the degree of the numerator, the top, is bigger than the degree of the denominator, there is no horizontal asymptote. Okay, so if the top has a degree of 2, the bottom has a degree of 1, there is no HA. There's different types of asymptotes. There's slant asymptotes, which are linear lines. You can have a parabola-shaped asymptote. You can have a cubic-shaped asymptote. You can have any sort of asymptote. Okay, those are your 3 rules for horizontal asymptotes. We're going to practice them right now. I got 2 examples to do, and then I'll give you some practice graphing. All right, we're going to scroll back to this page, 2x plus 1, top of 470. Okay, first thing, tell me the vertical asymptote. What can x not be? -1. Vertical is what makes the denominator 0. So in this case, it's -1. So our vertical asymptote is at -1. I draw that on the graph. There's our vertical. X is equal to -1. Horizontal. That one is 2. Why? Yes. Because they have the same degree, so you look at the coefficients. 2 over 1, so it's 2. So at 2, we have horizontal asymptote. Let's do the, can do it down here. Let's do the y-intercept. That's when x is 0, right? If I put x is equal to 0 in this thing, what do I get? 0, right? Because the top becomes 0, the bottom becomes 1. 0 divided by 1 is 0. So I go 0. So there's our point. Now, we have to go through that point, but we can't touch any of the asymptotes. So how do you draw that part of the graph? Looks like that. All right. Is that okay? All right. Now, that's only half the graph. You need to graph something on this side of the vertical asymptote. So we can pick any point we want for x and see what value we get. What point do you want? -2. So if I test -2, x is equal to -2. 2 times -2 is -4. -2 plus 1, what's that? -1. So I get 4. So I'll just say test. So at -2, we get a value of 4. So we're up there. So you can't touch the asymptotes, so the graph looks like. Is that okay? All right, we're gonna do one more and then I'll give you some practice. That's all I need, by the way. You can sketch that, I'm a happy person. Can I turn it? All right, we're gonna go to the bottom of this page. I don't know what page that is. 472. All right. Here we go. So, what is wrong with the way it's written right now? It's not wrong, but what do we not? How is it different than what we've seen? It's not factored, so we got to factor it. What multiplies to -6 and adds to 1? -2 and 3. So the top becomes x plus 3 minus 2. The bottom, I'm going to give you the factored form. You need to be able to factor these on your own. Becomes 2x minus 3 and x plus 1. Okay, it's now factored. So, what are my vertical asymptotes? What makes the bottom 0? -1 and 3/2. Or we have vertical asymptotes at x is equal to -1 and 3/2. There they are. Boom. Okay, you can have multiple vertical asymptotes. If you had 3 factors, you'd have 3. If you had 10 factors in the denominator, you'd have 10 vertical asymptotes. Okay? Can you tell me the horizontal asymptote? It's easier when you're doing horizontal. So, what is my horizontal asymptote? 1/2, because the degrees are the same, so we look at the leading coefficients. 1/2. All right, we've got verticals, we've got horizontals. You should always do y-intercept. That is when x is equal to 0. Again, I would look at the unfactored form for this, because if you put x is equal to 0 into it, all the x's go away, right? What are you left with? 2, -6 over -3, which is 2. Does that make sense? So I get x is equal to 2. So if you wrote it as a point, it's 0, 2. There's your y-intercept. Oh, thank you. Y is equal to 2. So y-intercept is when x is 0, right? So I put 0 in for the top and the bottom. All the x's go away. I'm left with -6 over -3, which is just 2. So the y-intercept is 0, 2. All right, let's do the x-intercept. That is when y is 0. Now, this is going to become important on Monday. We're going to have a look at it first now. Sorry? The y-intercept is, then you get y is equal to 2. So that's the y-intercept. When we sketch it out, you'll see. I'll mark that point. Okay, x-intercept is when y is 0. So if I put y is equal to 0 in here, I end up with this. Now I'm going to use the factored form for this. You'll see why in a sec. I asked you to solve that for x, what would be your first step? No, this is just an algebra problem, and I said solve for x here. Well, there's nothing to cancel, right? You would if you could. Sorry? Multiply them back out to get that. Okay, so if you do that, I have a 0 here. The idea is you want to get your exactly what you want to do. You don't want you want to get rid of your variables down here. You multiply these up. When you do that, 0 times anything is 0. So you end up with this. What does x equal? -3 and 2, right? Does everybody agree with that? Those are your x-intercepts. If you write them as a point, it's -3, 0, and 2, 0. Those are your x-intercepts. Now, what would have been the shortcut that you don't need to do every single time? You don't have to write all this out every single time. If you are asking for the x-intercepts, you just look at the numerator. That's it. You just look at the factored form. What makes those brackets 0 are your x-intercepts, and you're done. You don't have to do what I just did, okay? I mean, you can, but it's going to turn out to be the same thing every single time. So we've got x-intercepts, we've got y-intercepts, we've got verticals, and we've got horizontals. Now we can sketch the graph. So we're going to sketch it right here. Vertical asymptotes at -1. Let's guess where -1 is. And 3/2, or 1.5. Dashed line there. 3/2. Horizontal at 1/2. Call this 1/2. What other points do we have? We've got our y-intercept, 0, 2. So 0 and 2, so it's somewhere up there. And we've got our x-intercepts at -3 and 0. And 2, 0. So what does the graph look like? Do that again. He's right. So this one here has to go through this point, -3. You cannot touch this. You can't touch this. So the only thing I can do is that. This one over here, this 2, same thing. Has to go through that point. Can't touch any of those. So it looks like that. The middle one has to go through that point, but you can't touch anything. So it has to do a little mini parabola. It's not a parabola, but it looks like a parabola sitting in the middle there. Okay? Is that okay? Mark your vertical asymptotes. Mark your horizontal asymptotes. Mark your x and y intercepts. Sketch the graph. All I want you to do is number 1, A and B, 2, A, B, D, and E is the tricky one. I've got the key in the sketch of the graphs. All I'm asking you to do is sketch the graphs. That's it. Okay?